The shape of carbon dioxide is determined by here are the options, WAEC 2018. See, you are asked to give the criteria or the factors that determine the shape of carbon dioxide. So come, I will show you how to answer these questions. Do not fail to follow these channels for more should you find it useful, and share it to benefit others. Okay, now carbon dioxide has two elements, carbon and oxygen. One atom of carbon interacting with the two atoms of oxygen. Now carbon has atomic number of 6, and then electronic configuration is 2:4, while oxygen atoms each has atomic number of 8, and electronic configuration is a 2:6, as what you see on the board. Now for better understanding, then I used X to represent carbon electrons and tick dot to represent what? Oxygen electrons. Now let's look at the electronic configuration. The L shell of the carbon atom is having 4 electrons, 1 2 3 4. That's why the L shell, and that L shell is a valence shell. Now while that of the oxygen has 6 electrons, 1 2 3 4 5 6. Look at it, 1 2 3 4 5 6. There are 6 electrons on each. Now during the interactions, what's happened? Now 2 electrons from these carbon atoms shares 2 electrons from these other oxygen atoms. Now that gives rise to this, and then it forms 2 shared P on this. That is 1 2. Pick these 2 to form 1 2 3 4. Now these other 2, take care of these 2. Just look at, assume that's how it's gone. Now we have the 1 2 3 4. Okay, now this forms shared P and shared P of the electrons. Now you know that each atom must attain octet configuration, and that will now make it to become a stable element, so how to become stable. So now in this case, this one has 1 2 3 4 5 6 7 8. It attains octet configuration, and this 1 2 3 4 5 6 7 8 attain octet configuration. And the carbon atom, being a central atom, also has 8 electrons. Now it forms a shape like this. Carbon is here. Now 1 2. This one pair. This carbon atoms pairs to 2 oxygen atoms, now forming a linear shape. What makes it to form this linear shape is because these valence electrons here push themselves away so as to prevent the net repulsions. That is according to valence shell electron repulsion theory. So now once this has happened, the phenomenon that causes this is what we call repulsions between electron pairs. So the correct option to that question is a C. Please do not fail to follow this channel for more of this kind. See you next class. I love you all.